developer, DevOps guy at the Information Network of Arkansas. I imagine some of y'all are probably familiar with us, and I'll let Joseph introduce himself.
Joseph Yancey, also a software developer at the Information Network of Arkansas. I worked for a couple of years at another company you guys might recognize, Rockfish Interactive. It was kind of an agency and did a lot of AWS stuff there as well. How many of you guys know anything about AWS, have actually hosted stuff on AWS? Production stuff on AWS? Okay. It's actually pretty good.
We can't lie to them then. They actually know what we're talking about. All right. So we're going to kind of frame this talk around a website called iDriveArkansas.com. This is our baby that we built, and currently it's our only site that's hosted on Amazon.
Oh, Gov2Go.
We have another one called Gov2Go, and my computer's going to sleep.
Password's too complicated.
Mm-hmm. Security and stuff. All right, we're back. Okay, so we built iDrive on Amazon because we originally had it on a very monolithic architecture that we self-hosted. This site's kind of weird because there's no such thing as a consistent load for us on it. We either have like 10 people on the site, or we've seen spikes up to 1 million an hour. The variability there makes it very difficult to kind of have like a monolithic architecture pattern, because scaling up, scaling out, beefing up our stuff when we need to is difficult. Scaling it back down after the load's finished is difficult.
Well, and with the nature of this site, when our traffic does spike, it's winter weather events. So we can't just get in our car and like drive down to the data center and do anything. So we're like stuck at home. So
yeah,
we're kind of stuck there.
Yeah, we should touch on what this site is just real fast, just so you kind of frame this. This is a travel information site. Basically, if you're traveling through the state of Arkansas, being an Arkansan or outside of the state, you can pull up the site, figure out where traffic is, where construction is, where accidents are, all that fun stuff. It's kind of cool. It's maintained by the highway department, and we just do all the technical stuff for it, but they come up with all the ideas, prettiness, so.
Prettiness.
Yeah, it's not that pretty, but. Okay.
Left and right, yeah. There you go.
So first off, we're going to kind of take you through some of the terminology, just if you're not familiar with AWS, because they like to have their own little names for everything. They don't just call it a server, they call it EC2. They don't just call it Memcache, they call it Elasticache. So we're going to kind of take you through some of those real quick, just so you're not blown away when we start dropping all these names here. So starting off is IAM. It's what they use for access management, authorization, authentication, and it's kind of a loaded topic. The gist of it is that you have users, groups, and roles. Your users are people who are going to log in to AWS and do things. These are going to be, so your sysadmin there is going to have a user account. I have a user account. Everyone else has a user account.
Think of it like LDAP or Access Directory,
yes,
but for Amazon, and it actually can integrate with LDAP and that kind of stuff. So it can integrate with your corporate network. But this is what handles all of the account and access management for Amazon. Yeah,
they have some like crazy stuff where you can authenticate with Facebook and whatnot. I don't know why you would want to do that, but you can. Yeah.
Don't use your Facebook password for your Amazon account.
Yes. LinkedIn, maybe? Just kidding. Okay, so this is just a little preview of the dashboard here. These are screenshots. These aren't live. We don't do anything live because it's scary. No demos. So this is my account in Amazon. You'll notice through here we have some stuff blurred out. It's just because we don't want to give you all of our information, sorry. But so how this works here is you can attach policies. Policies are JSON documents that define what you can and can't get into. They're dead simple. They get very complex because there's so many different resources within the Amazon sphere, but the policy document itself is very simple. It's literally like EC2 management console. You can add new servers. You cannot do X, Y, Z. So they're pretty straightforward. And then the next tier to that are called groups. Groups are collections of users. It's that simple. It's basically, think of it, if you want to assign a policy to a certain group, so you may have a sysadmin group that they can do everything in AWS. You're going to put your sysadmins in that group, and then you don't have to manage the policies on a per user basis.
Yeah, or you may have a developer group, which we actually are for this. So in my developer account, I can't actually change anything, but I can read anything, I can see the status of anything. But if I need to make a change, I need to actually go like request a change with our change control system with our sysops.
Right. And then kind of the third tier to that are roles. And what roles are basically, they're very similar to the policy management for users, but for actual Amazon entities talking to other Amazon entities. So if you have an EC2 server that you want talking to Elasticache, you've got to set up a role that allows that. And whenever you like spin up EC2s, and we'll cover what EC2s are in a second, you put them in a certain role when you actually create them, and then they have all those permissions. It's kind of auto-magical how it happens within AWS, is that it just allows it. You don't have to set up any firewall stuff, anything like that. Out of the box, we'll touch more on the firewall because it's really complicated down the road. Speaking of complicated firewall stuff, VPC.
The VPC is, so think of if you had a data center on your own, you've got your servers, you've got your load balancers, your database, everything that is in your data center. This is kind of the wrapper around your like virtual Amazon data center. So anything in your Amazon environment that pertains to this particular app is going to be contained inside your virtual private cloud. You can have things in there behind the firewall, so they're not externally accessible. You can put things kind of in the DMZ where it is externally accessible.
Yeah. You got internet gateways, NATs, all within here. It's basically your own little network, and you'll have a VPN connection into it. If you so choose, you don't have to. You can leave it publicly accessible, but for iDrive, we have ours to where you have to sign on to the VPN to get to the database, to get to anything else.
Yeah, we have like our VPC allows port 80, port 443, and then our actual VPN, and that's all that it actually allows in. So if I need to connect to the database server, I have to VPN into our virtual private cloud, so I can then get access to the database server or Redis or anything.
Yeah, and you can get as complicated as you want with your route tables and ACLs and within your VPC. It very closely mirrors how you would set something up like on premise that's not in Amazon. There's really not that much difference from a networking perspective, but just know that you can set it up as secure or insecure as you want using the VPC. I don't know enough about networking to get much deeper than that.
Yeah, our sysops people handle that side.
Yeah, they're much smarter. So here's just kind of the dashboard here. Amazon has their own like VPN service. We don't use it. We actually use OpenVPN, but you can use theirs, and it takes some of the setup out of it.
I think the only reason that we don't use it is because it didn't exist whenever we built this.
Yeah, so. Amazon has an answer for quite literally everything. They have some implementation of any concept or thing that you can think of they've built within the AWS sphere. You don't have to use it. We use them for probably 85% and then use other open source technologies for the rest. So, all right. EC2. This is probably the one that most of you have heard of. Even if you aren't like fully drunk on the Amazon Kool-Aid, you've probably used an EC2 at some point. You can access them with their free tier. They have what's known as their free tier, and you can get what's called a micro EC2 instance, and you can run it for a full month for free. It's kind of cool. Their micro.
It's a year.
Say what?
I think it's a year, isn't it?
Yeah, it might be a year actually that you can get free use. And we've actually found that their micros are like kind of surprisingly beefy. Like they're not just a little piddly server. You don't want to use them for your production workloads, but for dev environments and stuff, they're kind of awesome. I was actually shocked at how fast they were. So here's kind of the management console for those. It's really as simple as like going and clicking launch instance and entering whatever role you want, and then setting up some real basic storage stuff around it, and then you've got a server spun up. You can tell it if you want a public IP or not, and then you can set up all that networking that we've talked about on top of that. But if you just need a server to run some code on, you can throw one together in like 5 minutes with this. It's pretty cool.
But you can't trust EC2 though. Like, it may very well go down. So don't spin up an EC2 server, log in SSH, and do a bunch of stuff manually, because if it dies in a month, you lose it, you're gone. They're not going to protect that for you unless you do your storage behind elastic block storage. But you can actually get around that with Elastic Beanstalk. Is that what's next?
Maybe, I don't know. RDS is next.
Okay. So RDS is your relational database service. That is literally MySQL, SQL Server. Actually, we've got the list on the next one. So yeah, so Amazon Aurora is Amazon's custom database server. It's crazy fast, crazy scalable. They run it across multiple data centers at the same time. It's really cool. It's also really expensive. So we don't use it.
Yeah.
So because it's really expensive. So MySQL and Maria are basically the same thing. It was MySQL, and then Oracle came along, and then they split off and did Maria. We're currently running, production is MySQL. Our staging environment is Maria, because we're in the process of porting everything over to Maria. It doesn't actually require any code changes at all. It's the same environment functionally. It's just a little bit different back-end engine.
And we have a Postgres database too.
Yeah, we do have a Postgres database. So our Postgres database, we actually use it because it's a map website. We've got lots of geospatial data, and Postgres has some really cool PostGIS functions. Amazon supports that perfectly fine. We spin up a Postgres instance. There's one command in Postgres to basically say, hey, install the PostGIS module. It installs it, and we're done. You can also do Oracle and SQL Server. I've never touched the Oracle database. SQL Server works just like SQL Server. You don't get some of the nice Microsoft admin tools like you normally would if you can just log into the SQL Server. But it does function. It's a Microsoft SQL Server.
Yeah. Slight tangent too, if you're a big MySQL fan, I was reading the other day that they just released a new update that has a bunch of geospatial stuff baked in, a bunch of GIS stuff. I haven't used it. I don't know anything about it, but it looked kind of cool. So that's my take.
Before last week, it wasn't as good. I'll say that.
Yeah.
Can I ask, what's the difference between RDS and then just a EC2 instance with a database installed?
So with RDS, Microsoft manages, or not Microsoft, I'm sorry, Amazon manages all of it. So you can say in your RDS console, you can say, okay, spin up a MySQL instance. Okay, that MySQL instance needs to be cloned to a separate availability zone, which is basically a mini data center within the same physical structure. But then you can also say, hey, I need a backup copy of that to be in. So my main one's is in Virginia, and I want a backup copy in California or Oregon or whatever.
Yeah, and they handle replication, they handle patching, they handle all of your like just raw server maintenance that you have to do. They do backups, like you can just tell it, take a snapshot and then restore from a snapshot, and it does it for you. You can dictate your size a lot easier. You can actually change the size very easily. So if I say, crap, we're running out of space, I gotta go from a T1 micro to a medium or something, you can just basically tell it, I need a medium now, and it'll handle taking the snapshot, restoring your snapshot.
Well, and they handle all the storage for you. So instead of having to say, okay, let's use elastic block storage and then hope that that's performant enough, the storage that they use for RDS is tweaked to the database system. And we don't necessarily have any proof, but we kind of are guessing that they have a custom database engine that sits below all of these, and MySQL and Maria and PostGIS or Postgres and all that. It's really just kind of a layer on top of their custom storage system.
Yeah, it's the syntax constructs to interact with their underpinning database. So
Yeah.
we don't know that for sure. We just think it.
Yeah, that's a guess. But
S3 is another one that even if you aren't in AWS's organizations, then you've probably used S3 at some point.
Simple storage service.
Simple
instead of static file.
Oh, yeah. Okay, sorry. So S3 is basically an SFTP server on steroids. That's way oversimplifying it, but you can do static website hosting with S3.
I think you've got.
Huh? That's S3.
Yeah, that's what I was going to say.
Oh, okay. You can do static website hosting. You can do use it as an SFTP server. You can actually set it up to where you can have like clients upload files to this, and it will charge them instead of charging your user account. You basically would set up their billing information, and as they uploaded stuff, it would bill them instead of you. But you still own the account and manage all the permissions and stuff, which is kind of cool. You can turn on, like I was talking about with the static file hosting, you can actually just turn it on to say, hey, this bucket is a folder pretty much. That's not much more complicated than that. You can say turn on static file hosting for this bucket, and you can even define like headers. So if you need to do CORS headers or something like that, you can do that, and then you don't have to configure Apache. You don't have to configure anything like that. It just hosts a static site for you. You can set up DNS for it and everything, so it's pretty slick. It's super cheap too. So if all you need to do is just host a static website, S3 is a great route to go because super cheap, super easy to use. Pretty much any proper SFTP client that you use will have S3 like adapter of some sort. We use Transmit because we're OSX people, and you just type in your IAM credentials and it'll let you log in and upload stuff like SFTP. It's really cool.
They've got really nice APIs as well. So our primary stack is built on top of PHP. We use Fly System for any of our file system management stuff. In Fly System, you can say, okay, I'm dealing with this FTP folder or this local file folder. You can also say I'm dealing with this S3 folder. So as far as that's concerned, to us, it behaves just like any other file system. And so if you see here, we've actually got all these files. It's .geojson. And these are files that the map needs to be able to render different layers. So anytime anything happens in the system, so if somebody goes in and they close a road because there's an accident, it's automatically going to regenerate this layer. And the actual code that handles that will then rebuild this file and push it to S3. And then our actual app, the map app, pulls the files from S3 through the CDN. So
yeah. We'll touch on the CDN that you mentioned, CloudFront. We'll touch on the CDN in a minute here. All right, Elastic Beanstalk. This is our bread and butter. This is like basically why we went to Amazon in the first place.
It's black magic.
Yeah, other services like Azure and stuff, they have this, but we really like Amazon's way of handling this. So I made this up, orchestrated multi-server environments. It's kind of a buzzword here.
It's a good phrase.
So basically the concept of Elastic Beanstalk is you give it some code and you tell it some very basic information of how many servers you want, what size you want them to be, and then what it's going to do is it's going to spin you up a load balancer. It's going to spin up all those servers, handle all of the networking between your load balancer and your server. All that traffic stays internal, by the way, which we had a little discussion right before the talk started about keeping traffic internal in Amazon. Long story short, do it. Keep your traffic internal if you can. Going out over the internet costs you, and it's really slow. But all traffic's internal there. You can tell it the same kind of like role stuff that I talked about before. So you put all the EC2s that it spins up underneath this Elastic Beanstalk in a certain role group. It's really cool, and the scaling parameters we'll touch on here, not there, here. So here's the auto scaling for it. This is how simple this is. It's can you guys see this? This may be too small. I'm not sure if you guys can. All right, let me.
Kind of.
And it won't let me blow it up either. It's fun. Oh, that's a bummer. Okay, well, I'll just kind of go through this. So up here is your minimum instance count. So this is how many servers at the very minimum you feel comfortable running. Your gut reaction is going to say to set this at 1, but you don't want to do that because it takes time to scale upward. It doesn't matter what service you're using. If you get slammed with 1 million people in a course of 5 minutes, you can't scale fast enough to get up to that point. So you don't want to set that too low. You want to have kind of a minimum, like this is not going to be able to handle the load, but it'll at least handle it well enough for us to start scaling and catch up easier.
Well, and just one isn't actually going to be reliable. If you just have one and something happens and that server goes down, something in Amazon's environment, something that you did, if that server goes down and you just have one behind your load balancer, you're screwed.
Yeah.
If you have two behind your load balancer and you lose one, your load balancer can still route traffic to your other one.
Yeah. And then you have your maximum instance count. You want to be careful with this because, like anything with Amazon, if you use it intelligently, it's not too expensive. If you go and throw like 100 in here and it starts scaling out of control, yeah, your bill is not going to be pretty.
It also won't let you exceed your total. So your Amazon account, let's say you're allowed 20 EC2 servers, and if you need more, you actually have to call them and ask for more. That number won't let you exceed that. So if it's trying to scale up past that, it's going to start restarting servers thinking that there's something wrong instead of just continuing to scale. So if you hit 20 and it needs 21, it's just going to start restarting servers.
So your scaling triggers, you can get real crazy with your scaling triggers. You can scale on latency, number of requests, CPU load, memory load, disk I/O. It's all kinds of different
It really depends
parameters.
on what your app is and the way that your traffic happens.
Exactly,
so
right.
With us, it's just the web app. So
yeah.
it-
And we played around with some of the scaling triggers, figuring out what worked best for us. We used a service called loader.io. It basically, you tell it, hey, throw like 1 million requests at my site, and it'll just start hammering it. We use that to kind of figure out what the best parameters to scale on, when to scale, how much to scale, and basically found that sweet spot of constantly being able to keep up with the load that was coming in without throwing too many EC2s at it and running our bill up through the roof. So if you're going to do this and you're worried about having very high traffic events, I would definitely do some research, read some articles. There's no one size fits all. There's no way to just tell it like scale when I get overloaded. What is overloaded? Is it disk I/O? Is it network? So this lets you really get configurable with it.
Well, and if your traffic, like if you know that there's going, like for us, if we know that winter weather is coming this week, we can go in and we can up the minimum. So we can say, we know we're going to need 4 on average, so we can pre-scale that.
Yeah.
You have a question?
So when it scales up, obviously you have to pay for the instances.
Yeah.
But do you also pay for the beanstalk technology itself?
No, that's actually a really important. I'm glad you brought that up. So none of their orchestration services, being Elastic, Beanstalk, any of that, you don't pay for any of that, of their actual like orchestration of it. You pay for the resources utilized. So you pay for the EC2s. There's like a networking charge too of just how much traffic's going over the wire, so you'll pay that as well. But you don't actually, the fact that Elastic Beanstalk had to scale your system up, you don't pay for that. You're just paying for the instances created. So, and that goes for all of their stuff. They have something called CloudFormation, which will build out your infrastructure stack. You do not pay for CloudFormation. You pay for the instances created.
I think there was another question in the back somewhere. No? Okay.
Last thing about Elastic Beanstalk, it deploys after you tell it what version of your code you want deployed, and that's basically defined by a version number pointing to a file out on S3. It deploys your code for you. You don't have to do any of that. It just magically happens. You can set different Elastic Beanstalk types. They have a Docker type, PHP, Java, .NET, others, and that kind of tells Elastic Beanstalk, okay, well, this is the kind of code I'm going to be running on it, so I need dependencies installed. I need to run Apache if I'm going to be on PHP, so on and so forth.
Well, with Elastic Beanstalk, let's actually go from kind of a higher level of what Elastic Beanstalk does. So for us, we have our app. It's a PHP app. And if we need to deploy it, we have a build script that zips up the app, puts it out on S3, and then makes an API call to Amazon. So all that we tell Amazon is, hey, this file out there on S3, deploy that to this EC2 instance or whatever you want to call it. It will go in, use all of the settings that we set up, take that zip file, deploy it to each of our EC2 servers. If we didn't have any of this set up, it would go ahead and set up the load balancer for us, set up the EC2 instances for us. If we had it programmed for RDS, it would spin up our RDS instance. Yeah. It handles all that. So all of this whole thing is the magic of Elastic Beanstalk.
Yeah, and you don't have to tell it like where on the file system your code lives. You don't have to set up Apache,
Yeah,
document
it handles
routes, anything like that. Yeah. Yes, you can set up alerts for any action in AWS. So our sysadmin's phone starts blowing up. Like if this thing scales up or down, he'll start getting text messages, emails. You can set up alerts for literally anything that it could possibly do. And they support like text, email, Slack, you name it.
But it all goes through the simple notification
Yeah.
service, right? SNS.
Yeah.
Okay.
I'm going to keep chugging. We're on time. Elastic Cache is Memcache or Redis. Simple as that. I don't want to go too deep into that.
Yeah.
That's really all it is. It supports some scaling, clustering stuff out of the box for you, so you don't have to set it up manually. That's as simple as it is. CloudFront is a CDN and WAF. You set it up to sit either in front of a domain or in front of an S3 bucket, and it will do all the great things that a CDN does. And as of the reInvent conference last year, they released their WAF, which is who in here, does anyone in here not know what a WAF is? Okay. A WAF is a web application firewall. It's basically a firewall that does a lot of security stuff. It'll strip out SQL injection, cross-site scripting. It'll catch some of that stuff before it even makes it into your app to where you have to worry about it. It just kind of makes sure that the stuff that's actually getting through to your app is fairly cleaned up. So this is just kind of you can set up SSL with it. You can use your own certificate.
Yeah, so you point your DNS to it, and then it routes everything to your load balancer.
Yep. So here's you've probably heard some other talks talking about how complicated the dashboard is. It's really complicated, like it's super confusing. I've got a base level certification with AWS, and I still don't know what half this stuff is. Again, like I touched on earlier, they have a solution for everything. They have a custom Amazon solution for everything. So if you wanted to, you could come in and use their stuff 100% and not actually use like a single open source product or build anything yourself. You pay for it, so it's up to you of kind of your balance of how much you want to build yourself, how much you want to use of theirs. Some of their services work a little differently than the concept that they're trying to emulate, so just keep that in mind. Like for example, they have something called SQS, which is Simple Queue Service. It's similar to Beanstalk D, but not exactly. And Beanstalk D, RabbitMQ, depending on your queuing service. It's similar, but not exactly. So it's just something to keep in mind. To make sure you do your research if you're going to embrace one of their technologies to make sure that it works exactly how you want it to work. Okay, so we're going to kind of walk through what our old infrastructure used to be for iDrive, and then what we're running now to show like why we did this and what exactly we did.
Were you going to drive?
Yeah.
Okay. I'll steer.
I'm going to have you talk since I need it.
Here.
Okay. So before, we basically had a single load balancer that had 2 app servers underneath it. These app servers we actually shared with other systems that we as Information Network of Arkansas host. A key one was property tax. That one receives like a crap ton of load, and it would interfere with iDrive if we had a spike in property tax and people were on iDrive. It's not cool because property tax makes us a lot of money. We don't like things interfering with it. So we had a load balancer, and then we had a database. This database got replicated over to a slave, but this was not a clustered database setup. We tried that for a while, and then it didn't quite work, so we're back down to one database. Scaling this is not easy when you're hosting all this stuff. If we need to add an app server to this pool, we had to have a sysadmin go out, manually build a server, manually set up all the configuration for it, manually wire it into the network, open all the firewall rules, get it in rotation with a load balancer. It's not a quick
And
process.
clone every app over to it, not
Yes,
just
yeah,
iDrive.
clone the code, the file system over there, set up all of our NFS mounts that we have. It's not quick, it's not easy, it takes time, it costs us money. It's kind of a pain in general. So we moved on to Amazon, which I'm going to let Joseph draw.
Okay, I'll draw it. So our Amazon environment, we have the virtual private cloud, so one giant box that everything lives in. And everything is using Elastic Beanstalk here. So Elastic Beanstalk handles our load balancer. I drew that earlier. So we've got the load balancer. The load balancer spins up, EC2 spins up the app servers with it. So we've got EC2, or Elastic Beanstalk spins up the app servers. Okay. So we've got app servers here. We've got RDS handles our database server. So we've got RDS, which is easy to spin up to a larger server. So if we decide we're getting too much traffic and we need to be able to scale up our database server, we can spin it up to a larger server. We're using one of the smaller ones that they have, so we have a lot of room to spin up there. And then if we need to scale out, we can pretty easily scale out with Amazon Stack as well. So we also have Elasticache, which is just Memcache. Well, actually, we're using Redis is what we're using. But we've got Elasticache for our caching system. All of this is handled for us, managed for us by Amazon. It's really easy to spin up new things to scale, handles all that magic for us. If Elastic Beanstalk determines, hey, we need new EC2 servers, it'll do it.
Yeah, one thing that was kind of funny, so when we first set this up, we were super paranoid and like none of us would sleep. We'd be up kind of watching this thing every time we knew that if there was like a big ice storm coming through. Big ice storm in Arkansas means like it snowed. But
hey, it shuts down. Come on.
Yeah, we'd be up all night like watching this thing, make sure it scaled when it was supposed to, and just sitting by our phones waiting to get that text that stuff starts scaling up. It just works. Like we haven't had any issues. We've gotten to the point now that we honestly we just don't even think about it. It just kind of happens. So it's very reliable.
We do have CloudFront that sits out in front, which handles if we get a DDoS attack, it handles that for us. So instead of before where everything was just going straight to our load balancer, if we get DDoSed, our load balancer crashes, our app servers crash, then we're done. That's it. And there's no way to spin up quickly to fix anything. We've got everything behind Cloudflare right now, so all that's handled for us. S3 for file storage, we don't have to worry about, here's an actual server sitting out there with files that we have to worry about the disks going down. We don't care. Like, Amazon handles that for us.
And if we told our sysadmin that we wanted to hook up a CDN on top of our SFTP server, he probably would have shot us. So
yeah, he would have shot us.
Yeah.
So with all this environment, so everything is handled by scripts. So if Amazon, like if a bomb lands on Amazon's Virginia data center, all we have to do, because we have backups of all this stuff, we run our scripts and point it towards the Oregon data center. And it spins up this whole environment for us magically. So instead of, if a bomb landed on our data center here in Little Rock where we had our old setup, we're down. I mean, that's that. We've got backups and we'd have to go buy new hardware and put it in a data center and it would take us a week or so.
Yeah.
This, we can have it back up in a couple of hours. Like tested, we know we can have it up in a couple of hours.
And
Am I missing anything? I feel like I'm missing something.
I don't think so.
Okay.
Yeah, as I kind of mentioned, it's been very reliable. So I want to talk about some of the uptime and costs, because if you're in any like position where you have to worry about, that's probably what you're most concerned about with Amazon. So with this stack, the bill that we're paying pretty much every month, we've had this running long enough to where we have a pretty good average. We pay roughly about $2,000 to $3,000 each month, and that includes our production stack, our dev stack. Keep in mind that includes months that we have to scale up, and we may have 10 of these EC2s running there. We've had to bump up our database once before because of load.
Well, and we've got an EC2 instance that handles our VPN. And
Yeah.
We've got a another server that just handles a bunch of scripts for us. And so it's more than just what we drew here for that cost. Though.
And we haven't done enough to limit our costs on it too. The Amazon pricing model is one of the most confusing things I've ever seen in my life. And so trying to it's not as simple as just dropping your costs by scaling back a little bit. There's a lot of tricks, a lot of ways that you can kind of look into it. I mean, there's consulting services out there that will come and evaluate your infrastructure and figure out how to save you money. So with that said, it's not easy, but I think that's kind of a shared thing with any hosting platform, really.
It's on par with pretty much any of the other cloud servers, and actually hosting this in your own data center and having extra people to have to keep up with it all. And
we are saving money over hosting in our own data center due to our costs that we have to pay to DIS and due to just some of the maintenance. I mean, we have to have a sysadmin drive over there and replace the server occasionally if the hardware goes out. That costs us money and time, where with Amazon, we don't even know that it goes down. It just gets replaced. So that's pretty cool. Uptime, we have seen it like, I think from looking at it last, we had 99.9 with 5 nines, which is really great, especially for a state website. Yeah, I mean, we're not, at the end of the day, we're not Google, so, I mean, keep that in mind. So it's been very reliable. That was the other thing that we wanted to move to this for is the highway department. They have very high expectations of us, and going down during a winter weather event was just not an option. It was kind of, we will lose the contract if we have issues.
Well, and it's more than that. It's you get drug up in front of the legislature, and we don't want to be standing up in front of the state legislature because they're not nice people.
And so that was another one of our inspirations to move to this. Network latency, unfortunately, I couldn't find like a good way to report that, because our main place that we would look at load time is our API, microservice, you could call it, and it's kind of a front end to a lot of third-party APIs. So like we were looking at it, and a lot of our times were like 2 and 3 seconds, but that's factoring in the fact that we had to spend 2 seconds of that to contact a third-party API. So unfortunately, I don't have any good numbers on that. You could look at the iDrive front-end site for load time, but it's going to be absurdly quick because it's just a static page, more or less, that's driven by APIs.
The front-end site doesn't, like, it literally pulls up the Google map and then hits all those GeoJSON files to render the layers. So those GeoJSON files are all built either by scripts or on demand by the back-end admin server.
Right. So we've been very happy with it. I honestly can't endorse it wholeheartedly over any of the other services, but that's largely because I don't have that much experience with your Azures, with some of your Google Clouds, some of your other services out there. At the end of the day, Amazon Web Services, it doesn't do anything that you can't implement in-house. It just does it way better than you want to spend the money and time to implement in-house. That's the general approach to it. It's kind of a misnomer that it's more expensive than hosting your own stuff, because if you've ever hosted your own stuff, you know that servers cost money, electricity costs money, all this stuff costs money, and these costs are kind of bundled into your AWS bill at the end of the day. And because they're such a big company and they can have so many servers, so many people, they've got incredible contracts with Cisco, with some IBM, with some of your heavy hitters. They can get this stuff a lot cheaper than we can too. And so all that cost is kind of, you realize some of the benefits of that.
Yeah, like you can go buy servers and stick them in a closet and plug up an Ethernet cord to it, and you'll have a working server, and then it'll go down in the middle of the night, and you've got this rat's nest of shit that you've got to deal with. So with Amazon, you don't have to. We've got a couple questions here. CloudFront does cost extra. I'm not sure how much, though. Do you know?
I think it's based on your traffic across it, which most of any of their networking services, that's how they charge you. Is they don't charge you for the fact that you have a CloudFront distribution. They charge for your traffic across it. I don't remember kind of what we're paying for that individually, to be perfectly honest. I don't deal with too much of the pricing for it.
Was this the last slide?
Yeah, I think
okay,
we're pretty much done with
we
our
can go ahead and
talk
move
at
on
this
to
point,
questions.
so
There was
feel
one
free to
over
ask some
here.
questions.
How are you guys managing your application loss with the Beanstalk setup? Are
Well, Amazon actually handles the logs for you. So you log into the EC2 panel, and you can actually just say, give me the logs for these servers. And it'll give you a zip file that has all the logs in it. So you don't have to manage or think about your app server. It handles that for you.
You can alert on those logs, like if you're dumping them in, you want to monitor. Like
Yeah.
CloudWatch, is that what you
Yeah, CloudWatch. Yeah, I was about to say they have that service, CloudWatch, that you can have it monitor any number of different parameters throughout the AWS ecosystem and alert you if certain events cross thresholds.
Yeah, and this is where all their products kind of interconnect. So CloudWatch monitors your EC2 instances for you. If it needs to notify you of anything, it sends a message over to the simple notification service that they offer. Simple notification service, you can say, send me a text message, send me an email, tweet it, whatever the hell you want, basically.
Yeah. And it's kind of cool in a way because Amazon, they use their own services for other services that they have. And so it's kind of, I mean, they're what's the saying?
They eat their own dog food.
Yeah, they eat their own dog food. Is it dog food, really?
Yeah.
Okay,
yeah,
well, they eat their own dog food because they, that sounds so weird.
It does, but that's what it is.
Yeah, so I mean, they're like, when you get an email, it came from their email service. It didn't come from SendGrid. It didn't come from some other service. So it's kind of cool. I mean, they're using the products that they created, and so they have every intention in the world to build a good, solid product because they got to use it. Yeah.
Do you know how this compares to Google?
How it compares to Google Cloud is a question. I can't speak to that. I've logged into Google Cloud. I have an account, and I think I spun a server up at one point, and that's my extent.
You have more experience than me with Google Cloud.
Okay. Yeah, we haven't used it, so unfortunately can't speak to it. I don't know if anyone else out here has used both that they could speak to it better. Yeah.
Just want to say, if you're a Microsoft house and you start spinning up Windows servers and Microsoft SQL servers, you will start getting licensing surcharges for those.
Yes.
That makes the pricing even more complicated. And of course, Azure doesn't have that because Microsoft's not going to charge themselves licensing.
Mm-hmm.
So if you're not on PHP, MySQL, then AWS may not be a good deal for you.
Yes, that's a great point. That if you are a Microsoft house, you do have to handle some of the licensing charges for Microsoft. Same applies to SQL Server. I think the same applies to Oracle Server that you have to
And
pay
Red Hat,
for.
I believe.
If you're using Red Hat,
IAM.
Linux, then you will have to pay any licensing. Yeah, unfortunately, AWS doesn't just like pay for your licensing with that kind of stuff. It'd be great if they did, but they don't. You still got to pay for that.
They're not benevolent.
No. They also have this thing called Amazon Marketplace. They have, it's called an AMI, Amazon Machine Image, maybe? That
Something like
sounds
that,
good.
yeah.
Okay. They have hundreds of thousands of AMIs that people have built, community people have built. Some of those cost money. So like WordPress has a WordPress AMI. So you would spin up an EC2 instance and tell it, I want to use the WordPress AMI. Bam, you have WordPress running. You have to pay for that, for licensing, for stuff like that. So just something to note. A lot of those AMIs, they typically charge you by the hour from what I've seen. So the hour, you pay a certain charge for each hour that the server's up and running. And it varies greatly depending on what software that AMI has.
It's like it's kind of built into your EC2 costs, right? Like you spin up an instance of Windows Server,
Yeah.
2014,
Right.
and it's kind of built into your EC2.
Exactly. Yeah. Yep. Yeah, what's up?
On Elastic Beanstalk, is it spinning up new instances, or do you have the pre-set up EC2 sitting on it?
It's new instances. If you actually look at the logs off of the server, if for those of you who couldn't hear, he was asking Elastic Beanstalk, is it spinning up new instances or instances that already have all your stuff installed that are just kind of sitting in the background?
And is it using like OpsWorks to configure those so you can do chef scripts and do all your exploits to get everything set up, or is it?
I believe you can. So they have, for Elastic Beanstalk, they have this thing called EB extensions, and it's basically a directory that you upload with your code base, and you can put all kinds of commands in there. They have a bunch of like Amazon proprietary commands that you can run that will do different stuff, or you can just run like a bash command. And so you can do a bunch of configuration like that. If it's actually using OpsWorks, I don't know, but that's probably an option. You could absolutely integrate Chef or Puppet into that.
We do have it, like we are actually using that though. So whenever we run whenever we need to upgrade our code and we send them a new zip file, on all of the different app servers. Well, actually, there's one that you can say this is a leader-only script. So on the first one that it gets ran on, it will actually go in and run that script, and we have that handling our database migration. So that, like, we tell it upgrade this code, it goes out and deploys the code, and the code runs the Think scripts that actually handle our database migrations for us.
Right. And they have a new, it's fairly new. They have a new Docker type Elastic Beanstalk that you basically give it a Docker file or a Docker image, and it will build a container or build a server out running your container on it. Again, it's kind of some black magic. It's what it's actually doing under the scenes, but that's kind of their newest. It's a good way that if you already have a Docker image that you just want to run on multiple instances and be able to scale, then you can just point at a Docker image and it'll take care of the rest. And in my mind, that kind of replaces some of the stuff that you'd be doing with the EB extensions directory, installing dependencies and whatnot. You're going to do that in your Docker file now instead of Elastic or EB extensions.
We had another question here.
Well, I was going to take a stab at comparing it to Google Cloud.
Oh, okay,
Okay.
yeah. I'm going to give you the microphone because they want us to.
This is a little bit more than I signed up for. Okay. So Google Cloud has an analogy to a lot of these things on here, and their pricing is extremely similar. You're not going to get a big price difference. I would say the biggest difference is with the IAM. Did you guys do a lot of configuring of access roles and rights?
Not really.
Yeah,
I
we
mean,
don't have a very complicated setup. There's people with infinitely more complex IAM setups than we do. We don't have a whole lot of stuff on here yet, so that's driving most of that.
Yeah, I found the IAMs to be just incredibly complex in Amazon. Like, you have to script it and stuff. Whereas Google Cloud has a concept of a project, and every single computing resource that you can buy in Amazon is related to a project, and then you can just invite people to your project.
Oh, okay.
So it's just the access rights are way different. That's probably the biggest difference. And then, of course, instead of Elastic Beanstalk, they would probably recommend like Kubernetes to deploy containers.
Yeah.
I think we're running low on time. Yeah, it's 9:20. Maybe we got time for one more question or so
Yeah.
in the back.
Is there an easy way to manage the instances, like do you have like a remote desktop manager or something?
I'm sorry, I'm deaf.
Like a couple of instances, like 20, 30 instances, EC2 instances. How do you manage, like how do you connect to the remote desktop? Like you use the remote desktop manager?
So, from my experience with Amazon, I'm sorry, the question is if you have like 20 or 30 instances and you need to connect to them and say run some command on all of them, how would you do that? In my experience, Amazon wants you to kind of stay off the servers if at all possible, especially with Elastic Beanstalk, is that you're not really meant to be SSHing into them. You can, but they don't make it easy. So I think a lot of that, you would kind of have whatever orchestration process you have in place to kind of run all those commands on it automatically, whatever that orchestration, whether it's something that Amazon's provided to you. They do have some service, I can't remember the name of it right now, that you can actually run stuff on a bunch of EC2s, but it's more meant for running like batch workloads, that if you need to process a whole bunch of data, you can run the same job on all these different EC2 instances. But I'm sure you could misuse it and do whatever you wanted with it, I'm sure. So.
There's like a Visual Studio plugin which you can use to run scripts on all this.
Oh, okay. Yeah, he said that there is a Visual Studio plugin that you can use to run scripts on a large number of instances. I don't use Visual Studio, so I can't speak to that. But
I will say that Visual Studio does have a really nice plugin to be able to deploy to Elastic Beanstalk. So you literally just install the Elastic Beanstalk plugin, and whenever you right-click and go to publish, instead of saying publish to a file system or to anywhere else, basically, you can just say, I want to go ahead and publish to Elastic Beanstalk.
Right.
And it'll handle that for you. It'll spin up everything.
And just
magic.
about any CI/CD system that's been created within like the last 20 years will do Elastic Beanstalk deploys.
Yeah.
So.
I think we're out of time.
Yeah, I think we're about out of time. So thank you guys for coming. Have a good rest of your day.